let us understand what kind of motion can a rigid body have. Now, try to explore this problem by taking some examples of motion of rigid bodies. Let us begin with a rectangular block sliding down an inclined plane without any sidewise movement. At point like P1 or P2, the block moves with same velocity at any instant of time. The block is a rigid body. Its motion down the plane is such a way that all particles of the body are moving together. That is, they have same velocity at any instant of time. The pure translational motion at any instant of time, every particle of body has the same velocity. Now consider the rolling motion of a solid metallic cylinder down the same inclined plane. Rolling motion of a cylinder, it is not pure translational motion. Points P1, P2, P3 and P4 have different velocities at any instant of time. We can see that here all the particles are not moving with same velocity at any instant of time. The body is therefore not in pure translational motion. The only possible motion of such a body is rotation. To understand rotational motion in a better way, let's take a rigid body that only has rotational and no translational motion. You can see a fan and a potter's wheel. The line along which body is fixed is termed as its axis of rotation. No more. There is a point known as instantaneous center of rotation, abbreviated as ICR, above which rotation is supposed to occur. The velocity of point about which rotation is zero. ICR can be easily found out. It is basically the intersection of two perpendicular lines to the velocity of two particles in a rigid body. Now, let us understand characteristics of rotation. In some example of rotation, however, the axis may not be fixed. A prominent example of this motion of rotation is top spinning in place. The axis of such a spinning top moves around a vertical through its point of contact with ground, sweeping out a cone. You can see O, which is the point of contact. The point of contact of top with the ground is fixed and axis of rotation of top passes through the point of contact at any instant. You can see the green line which shows the axis of rotation. Another example is oscillating table fan. We can see that the axis of rotation of such a fan has a oscillating sidewise movement in the horizontal plane about the vertical through the point at which axis is pivoted. Key point, thus, in more general case of rotation, such a rotation of top or a table fan, one point on a rigid body is fixed. Now, look at some more type of motions. You can see the motion of rigid body which is pure translational. In this figure, note P is arbitrary point on the body and O is the center of mass of the body. Sufficient to say, here the trajectory of O are the translational trajectory TR1 of the body. The position O and P at three different instants of time are shown as O1, O2 and O3 and P1, P2, P3 respectively. As seen from figure, at any instant the velocity of any particle like O and P of the body are the same. Thus, the body is in pure translational motion. The angle OP makes with fixed direction, say the horizontal, remains the same. That is, alpha 1 equals to alpha 2 equals to alpha 3. Motion of rigid body, which is a combination of translational and rotation. In the figure, note P is an arbitrary point of the body and O is the center of mass of the body. Sufficient to say here that the trajectory of O are the translational trajectories TR2 of the body. The position O and P at three different instants of time are shown as O1, O2 and O3 and P1, P2 and P3 respectively. In this case, at any instant, the velocity of O and P differ. Also, alpha 1, alpha 2, alpha 3 may also be different. Text. The motion of rigid body which is not pivoted or fixed in some way is either a pure translational or combination of translational and rotation motion. The motion of rigid body which is pivoted or fixed in some way is rotation.